Okay, welcome back students. So another very important topic which we are going to discuss today is the probability density function. As we have also discussed the concept in cumulative distribution function, where we have discussed the difference between a probability density function and a cumulative distribution function, I mean PDF and CDF. So what is basically the probability density function? You should keep in mind that here we are using the term probability density function. In some other location you will find the same thing with the name of probability mass function. Mass is basically a discrete quantity and density is a continuous quantity. Therefore, probability density function is a reserved word for continuous distribution function or continuous density function, while probability mass function is extensively used for the discrete probability function. So what is this? If let me change the color of my pen. So if capital F of x is the CDF of any function, then the PDF or probability density function can be found out by finding the derivative of cumulative distribution function, and the formula is this one. As we have also discussed the same thing while we were using the concept of random variables, and we have used a coin toss problem in which x or random variable is the number of heads which we encounter in 3 consecutive or 3 sequential coin tosses. So x is a random variable, and in that question we saw that basically if we had the values of random variable are 0, 1, 2 and 3. So the probability of 0 heads is basically 1 by 8. Okay, the probability of 1 head is 3 by 8. We have proved it. Okay, we have proved in our previous chapter as well, and in this chapter also. So 3 by 8 is the probability of getting 2 heads. Number of heads are basically 2, and similarly the probability of getting 3 heads is again 1 by 8. So what is this plot? This distribution plot is called the probability mass function, or when it will be in continuous form, it will be the probability density function. Now this is a probability mass function. Okay, in this book the same concept is discussed in chapter number 3. If you are using the edition 3, so the same concept is used in chapter number 3. But if you are using the second edition, the same concept is also been discussed in chapter number 3. So this is the probability mass function, and this is the basic equation of finding the probability mass function. This is the equation which is used for finding the derivative. You have also seen this equation in your FSC. So if capital letter is used for the CDF, the smaller letter will be used for the PDF. Okay, so there are some properties related to the PDF of any function, and the first property is that PD of any function will always be greater or equal to 0. It cannot be less than 0, because this is the probability. Okay, it is also the probability function, so you have to see that the value of probability cannot be negative. Okay, so this is the concept. Okay, let's move on. Okay, another property which we are going to see is this second property, which is asking you to find the probability of any range. Okay, if you want to find the probability from A to B, okay, how can you find it out? You will have to integrate it from A to B. You have to integrate the probability function, which is the probability density function, from A to B, and you will A to B, so you will get this probability in this equation. Okay. Similarly, there is another property, which is property number 3, and if you want to find out the CDF, this is the CDF. You want to find out the CDF up to point X. What will you do? You will add from minus infinity up to that point, and you will get the CDF. You will add all those points, because integration is basically the addition in continuous function. So as we have been discussing the continuous function, excuse me, we have been discussing the concept of continuous function, which is the probability density function. Therefore, integrating a value from minus infinity up to a certain point X, up to which you have to find the CDF, will be the required result. Will be the required results. The same concept we have discussed in CDF. Okay, there were basically two plots, which was one was PMF and the other was CDF. So we have discussed the same concept, in which you were adding all the probabilities and you were getting the PMF. Okay, let's move on. So this is the concept. This is the same concept. If you want to find out the probability in two values, in between two values or in any range, so this is the range. You have to find the probability, which is this one, this area. So how can you find it out? You have to subtract this one, function of value at this point minus the function value at this point, so you will get the answer. Excuse me. Similarly, the summation of the probability density function will always result in 1. If you are summing it from minus infinity up to plus infinity, or summing means you have been integrating it from minus infinity to plus infinity, you will get 1, which is basically the total probability law, because the total amount of probability in any subspace is always equal to 1. Okay, up to this point we have discussed the CDF and PDF, and what are the meaning of CDF, cumulative distribution function, and probability density function, probability mass function. So it's enough for this lecture. In next class, what we are going to discuss, we are going to discuss different random variables which are important, and the relevant examples of that random variable. The first of all will be the uniform random variable. Okay, so uniform random variable, and after the uniform random variable we will also discuss other random variables under important exponential and random variable, Laplacian random variables, and many other random variables which are very important to study. So after this class we will go through the distributions and what is meant by the expected value, variance, and what are the modes of different random variables. Okay, so it's enough for today, and I will see you in the interactive session. Please study all the concepts, and if you guys have any question, we will discuss it in the interactive session. This is the concept of the expected value. We will go through it in our next class. So I am basically aiming to take a quiz from you guys. It will be a very easy quiz, so I want you guys to get prepared for the quiz in the next class, or on Friday. I will announce it on Google Classroom, so I encourage you guys to study for it. Okay, thank you so much, and I will see you in the interactive session, which will held on very soon. Thank you so much.